Welcome back. Now, what we're going to do is we're going to start using some of these output parameters to represent our brick wall. Now, as I said in previous in-class discussions, all that the robot and in fact the parameters is just about points in space and alignment planes. But in order to see how things will look, we do need to sort of give them some sort of, I guess, modeling input to it. So what I'm going to do is we're going to represent our output, and so it looks like a brick, I guess. Now, to do that, I'm going to double click here, and we're going to make a box. If we go box by the center. Now the reason I've used box by the center is because it's easier way to work through the parameters from dividing a rail, getting a series of points, rather than trying to generate two sets of points to make a box from two corners. So if we look through here, what the input's looking for is a base plane and direction in X, Y, and Z. So if we look through here, what the outputs we've got a series of points, we've got tangents to points, which is a vector output, and then this is just a list of the values that have come out of this. So it's just a sequence of, as we can see, 230 keep adding on one after the other. Now, the dimension of the box is basically going to be our length, X, Y, and Z. And as you can see, it's just defaulted to the point that it knows, which is this center point at the origin, but we're going to tell it to actually put a set of points through here, boxes through there. Now the interesting thing is that you can see the difference between the connecting lines between these elements. This is a single line because this is a single parameter, whereas this is a different representation because this is a list of points going into it. So what it's doing is that it's repeating this box over a number of points through there. Okay, now as you can see, oops, sorry, wrong one. We have a set of bricks, but they're all kind of mashed on top of each other. Now if we look at that, part of the reason is that how it's created this box is that from the center point it's gone, it's like inflating a balloon. It's gone out the brick length X 230, so it's gone 230 this way, 230 that way, 110, 110, 76, 76. Now it's just because it's the way that the parameter works, and sometimes we need to develop these workarounds. In fact, to get our correct brick size to work for this box, we need to halve the value going into the box. Now, to do that, we can go into the maths and we can get a division operation, or if we double clicked and we just went divide, it'll pull up our division already. Now you can see here, here's our mathematical equation. So A, the item to divide, B, the number that we're going to divide it by. So we can get the number here, so we want the brick length to divide into half, but we need to establish an input parameter. Now we could use a number slider, but because it's going to be a standard value, what we can do is put in what's called a panel. Now to launch a panel, we go shift parenthesis keys. Now panels are useful because they can be used to input parameters, but they can also be useful to see what's happening at outputs. So I've just copied this panel that I've just made, and for example through here, if I wanted to see what was actually coming out of that parameter, you can see here that we can see this as a list. So what it's doing is that it's showing us all of the data coming out of that as a series of X, Y, and Z coordinates. And sometimes that's useful in reverse engineering someone else's Grasshopper routines, because if you're not sure what the parameter is actually doing, sometimes if you look at what the output is, it makes it a little bit easier to understand. So I'm just going to delete that. But in this instance, and I also use actual panels to use as labels as well, so you can actually use this as a text panel and just type in whatever you want there. So it's good as a auditing tool. Now I'm going to divide, just going to size this down a bit. Going to divide the length of our brick, width and height by 2. Going to halve it. So there's our input, and then I'm going to input that there. So you can see the effect is that it's halved the length of our brick. Now we can just shift, copy, Control C, Control V, and duplicate those, and then we put the different inputs. What have I done here? Sorry, we'll go into there, and we'll go into there, and then we'll go into there, and then into there, and now you can see our bricks relative to where they're sitting are more or less the right size. Now you could ask yourself, what's the point in actually duplicating these three mathematical equations, because ostensibly it's the same. Now what's important in Grasshopper is the way that information and data flows through, and the structure that it comes into, because it's a very sort of dumb piece of software really. It needs to be given very clear and explicit instructions. So for example, if we wanted to say, just as a test to see what would happen if we put everything through the one equation. Now to do that, we can then just pop that in there. Oops, we need to do a shift so we can add multiple values into there. And then if we just disconnect this, so we go disconnect, and then if we just ran it all through the one, and we get this really weird result, because what the list is doing is that it's just going in sequence, and we can see what happens if we go here, connect a panel to there, and in fact what we're doing is we're just getting 3 outputs based on the division of these 3 things in here. So that's not very helpful. So the way that data flows in and out of these different functions and effects is something that you're going to have to be very conscious of. So we're going to change that. We're going to pop that into there, pop that into there. We're going to disconnect. So to disconnect, we can then go disconnect the width, and if we right click on A again, disconnect the height. So now we've got the right outputs through there. Oops, that didn't go well. So we go to X, to Y. So there's a clear sort of pathway of data through. So we've got the right size bricks, and they're arraying across the set out rail nicely. But part of the issue is that they're all lining up according to the origin plane through there. They're not lining up with the planes that are tangent to the set out rail. Now remember I said about some of these outputs through here, we've got a series of points, but we've also got a series of tangents. Now what we need to do is to set up a series of orientation planes for these bricks to set out on. Now, to reorientate these bricks, we're going to set up a plane. So if we go into the vector, we can see there's a whole bunch of inputs or parameters that we can do to construct a plane. Now if we pull that down, we're going to construct the plane through here. Okay, so what we want to do is set up a series of origins. So it's looking for an origin point, it's looking for an x axis and a y axis. Now we have a set of origin points, which is the set of points coming out of the length there, so we can pop that into there. Now we also have a series of x-axes, which is this tangent. So if we pop that into there, and let's just turn off the box. Now to turn off that geometry, what we can do is we click on the box, right click, and you see here the preview, we'll click that off and we'll that makes the bricks invisible. Now what you can see through here, I'm just going to disconnect that there. So you can see here at the moment, currently, if we just set up a series of new planes through the origin, they're all lining up with the universal XYZ plane. Now if we plug in the tangent through here, they're all now picking up on that tangent output, so that they're all lining up with the tangent on the brick. So when we now plug in our points into there, preview it, you can see that those bricks are now lining up with the wall. Now we're almost there, but the one thing that we want to do is to add in the space for the mortar, because at the moment the bricks are just crashing into one another. So to do that, we're just going to add in a variable number slider, and we're going to call that the perpend width, and we're going to give it a maximum range of 0 to 20 mils. So that's the thickness of the vertical mortar joints. We'll pop that in there. Now what we need to do to insert the perpend through there is to add the width to the brick length. So double click, and we add, and then what we do is that we're going to pop that in there, pop that in there, and then we'll go and adjust the length. So we'll disconnect that and we'll pop that in there. So you can see now if we dial up the perpend width, it'll then start to space the bricks out more evenly. So that is our basic single course wall, which we will then start to add on to. Now we're going to save this, so save the current file, and what we're going to do is we'll call this simple routine stage 1. Okay, so we'll check back to the next level in future videos. Thanks.